Hello everyone, today we will look at a simple infrared remote control detection circuit. Through this circuit, we will understand the internal structure and working principle of the integrated infrared receiver. The integrated infrared receiver is a very common device in infrared receiving circuits, including household batteries, TVs and air conditioners. Similar infrared receivers are used. We know that infrared reception works at a specific frequency through a carrier wave. For communication, in order to prevent light of other frequencies, including visible light, from interfering with infrared reception, some filters and filtering circuits will be added to the infrared receiver to filter out other light and useless signals. As for the ordinary infrared receiving diode, there is no integrated circuit inside it. It will only filter the light other than infrared. So if you use an ordinary diode, the tube needs to add some filter circuits and amplification circuits outside it before it can be used. In this integrated infrared receiver, circuits including filtering, amplification, shaping, etc. have been integrated, so its external output signal can be directly used by the following decoding circuit. First, let's take a look at the internal structure of the integrated infrared receiver and its appearance. It is the internal block diagram of the integrated infrared receiver and its appearance. First, let's look at the right side. The integrated infrared receiver of these two structures is metal packaged with a metal shield on the outside. And this one is plastic packaged. The left side is its internal block diagram. Let's take a rough look at its internal structure. It mainly consists of an input gain amplifier, a filter, a demodulator, and a part of the logic control circuit. To form the common infrared remote control, the frequency it works at is generally 38 kHz, which is more commonly used. Of course, there are other frequencies. So, in the remote control we will see the fine oscillation of 455 kHz. And this fine oscillation will be divided by the frequency divider by 12, and its frequency is about 38. So, this infrared remote control is a working in special in the integrated infrared receiver circuit with a fixed frequency. There will be some filters that will amplify this specific frequency, and the light of other frequencies, including the infrared light of other frequencies, will be filtered out when it enters. Therefore, it is useless to the outside world. The interference of this light signal will filter it out. So what about the packaged integrated infrared receiver of the two appearances on the right? The internal circuit structure is basically similar, but its shape will be different and its pin ordering will also be different. This integrated infrared receiver generally has 3 pins, 2 of which are power supply positive and power supply negative. Both are powered, and this is the signal output. We see that there is an NPN YPE triode at the end of its internal block diagram, so its signal is similar to a switch. The pulse output of the signal is here. We are just simple. We just take a brief look at its internal structure. So what is the specific working principle? There is an article on my homepage that will give a detailed introduction. If you are interested, you can check it out. You can search for it. Next, let's go back to the circuit just now and take a look at its working principle. In this circuit, the front is the infrared receiver. So the above two are its power supply terminal, the positive VCC, and the ground terminal, which is the connecting terminal. Then the third pin is its signal output. First, this signal drives a 90122 triode, which is a PMP triode. Then, an LED indicator light is connected below the triode. At the same time, The signal output by the motor is sent to the Q3 behind through a resistor. The machine set provides a signal to its machine set, so the output of the infrared receiver on this rod will drive an LED to emit light through to triodes. The triode at the back will drive an insulator to make a sound. At the end of it, it will regulate the voltage of a resistor and step-down diode. The circuit behind it will work on a 5-volt regulated power supply. Then the infrared receiver, its working voltage is generally between 3 and 5 volts or 3 to 5.5 volts. So after the 9 volts come in, it provides the working voltage to the infrared receiving circuit through voltage reduction. The main function of this circuit is to use a relatively simple method to detect the quality of our common remote control. When the remote control is used normally, its output is after some carrier waves are modulated, some signals are equivalent to the encoding of some pulses. After internal amplification of the infrared receiver, some pulses of high and low batteries will be output at this output pin. Then after internal amplification of the infrared receiver, some pulses of high and low batteries will be output at this output pin. After internal amplification of the infrared receiver, the high and low batteries will drive these to, then you can see and hear the sound from the LED and the wind indicator flashing and making intermittent sounds with the pulse of the signal sent from the remote control. So we can roughly judge the quality of the remote control through this simple method. Then there is another simple way, that is, we can use the camera of the mobile phone. Use the camera of a mobile phone to capture the luminous headphone tube emitted by the remote control. We know that infrared light is invisible, so shooting through this camera will reflect the infrared ray on the screen of the phone. But with that method, we can only see whether the infrared remote control receiver, the infrared remote control transmitter, and its luminous headphone tube are emitting light, but we cannot see the pulse because of the reflection of the phone. It shouldn't be that fast. We can hear and see this circuit through this circuit. For example, this light-emitting headphone tube will flash with this pulse signal, so we can roughly judge the quality of the remote control through this circuit. The two types of packaged infrared remote control receivers we just saw in the block diagram and its physical picture have the same function and internal structure. The external pin ordering is different. So as long as its working frequency, we can look at the manual of technical parameters provided by the manufacturer. As long as its working frequency can meet the carrier frequency received by our remote control, it can generally be replaced. However, when replacing, what we need to pay attention to is whether its pin ordering is consistent. Today's video ends here. Thank you for your attention. Goodbye.